To investigate the dangling else problem, let's take a look at these two blocks of codes. The only difference between the two blocks is the indentation on the else clause. And there could be two valid questions here. The first is which if statement does the else clause belongs to? The second is what would be the value of A after evaluating the if statement. Indentation actually has no effect on how the compiler will interpret the blocks of codes. In Java, the else clause is paired with the closest possible if clause. In this case, the if B greater than C condition. So the code block here on the left is the same as the code block on the right with a pair of braces inserted. The result of the evaluation of the block of code would result in setting A to 30 at the end of the execution. We can also use a combination of if-else-if. The example here illustrates how it could be used to determine your grade if the cutoffs are set to 90 for an A, 80 for a B, 70 for a C, 50 for a D, and below 50 would be an F grade. Notice that it will make a big difference if the keyword else is left out. Think about what would happen to your grade if this is how your grade would be determined. Say if you have a score of 100, you should be very happy. But let's take a look at how your grade would be assigned. The first test, 100 is greater than or equal to 90. So far so good, you get an A. But when the program continues, 100 is greater than 80. So you are demoted to a B. The program will keep going until the grade is changed to D. Luckily, the else part won't be executed, and you still get a passing grade, but I'm sure that you will be very unhappy. While the if statement allows the selection of two possible paths, the switch statement allows more than two execution paths. Here is a diagram to illustrate the flow of control of a switch statement. Here is the syntax of the switch statement. The syntax of the switch statement begins with a switch expression together with the keyword switch. The switch expression would be of type char, byte, short, or in. The case values, value 1, value 2, etc. must be of the same type as the switch expression. The keyword break is used to exit the switch statement. It is important to remember that without break, the flow continues to move on to the next case until a break statement is found. Lastly, there is the default option. With the default keyword, this part will only be executed when no other case is matched. This is a useful schematic diagram to look at the action of a switch statement. Here, you have a set of switches labeled as case 1, 2, 3, and 4. When switch 1 is on, action 1 is performed, but it won't just stop unless there's a break in between. Similarly, when switch 2 is on, action 2 is performed, and so on, until the last or the default case is reached. Here is an example using the switch statement to illustrate how it could be used to determine the letter grades when the cutoff are set to 90 for A. So here, when someone score 100, 100 divided by 10 would give 10 as the result. Under case 10, there is no action, so we'll continue on to the next action, which would assign a letter grade of A to grade. For other cases, action will be performed depending on the evaluation of the expression, score divided by 10. If none of the cases is matched, the default case of assigning a F grade will be executed. Guess what will happen? You will take away all the appearances of the keyword break. I'm sure that you will not be happy because worse than what would have happened in the if-else-if example when the else was removed. The removal of breaks here would give everyone an F grade no matter what score you obtained. The switch statement here would actually do the same thing as the if-else statements that you have just seen earlier. In fact, anything that can be done with the switch statement can also be done with the if-else.